Let's talk about heat treatment and stress relieving. Many people confuses these two processes. Both of them serves a different purpose. So, what is a stress relieving? Stress relieving is a process to remove the locked up stress in the material which is developed during cold working, for example, or during welding. A lot of shrinkage happens, distortion happens. So the stress develops in the members. So to remove this stress, the material is heated to a certain degree of temperature and allowed it to be there at the temperature. We call it holding time, and then allowed to cool down. It's like you got a body pain and you just give an application of heat, you feel comfortable and relaxed. Now, why do you need to remove the stress? Stress can cause a distortion. Yeah. And so, therefore, you need to remove the stress. Number one. Second is stress also accelerates corrosion. You must have heard about the terminology called sulfide stress corrosion or stress corrosion cracking. If the member is highly stressed, it accelerates corrosion. So, sulfide stress cracking is another phenomenon when H2S attacks the material, and this is accelerated under stress when the material is under stress. So, it is a good idea to remove the stress from the component after welding. And certain conditions, certain situations, these are mandatory to do it. So, stress relieving is actually heating and keeping at the soaking temperature, holding temperature, and then allowed it to cool down. The temperature is around 600 degrees centigrade. It doesn't go beyond 600 degrees centigrade. It does not refine grain sizes because it doesn't go to that level of temperature when grain refinement can happen. Only because of the heat, material expands a little bit and then gradually cool down so the locked up stresses are released. I will show you the graph in all three in one graph. For example, this is stress relieving curve. So temperature is raised up to 300 degrees centigrade. So almost 100 degrees centigrade per hour is the range that you raise it up. And you take it to 300 degrees centigrade, so approximately 3 hours. From there, you raise it to 150 degrees centigrade per hour, and you can go up to 600 to 620 degrees centigrade and hold it for some period. And there is a thumb rule. So 1 hour for 25 of thickness. So if the plate thickness is 25 millimeter, you are going to hold it at 1 hour and then cool it down in the furnace up to 300 degrees centigrade. And after that, you allow it to cool in the air. So it should be much more rapid. After 300 degrees centigrade, they're allowed to cool in normal air. So this is stress relieving. Look at the temperature. It goes up to 600 to 620, 630 around that temperature. So the purpose is removal of the locked up stresses developed during welding, cold welding, for example. Now you have to, for different members, you have to put thermocouples and monitor the temperature. So there'll be a graph coming like this, and this is a typical graph that shows stress relieving. Normally done in a descent of a pressure vessel because there are a lot of stress developed in the forming. The plate is formed, or the crown radius is there, knuckle radius is there. So there are a lot of spinning process cold working process, a lot of stress is developed on those. So to remove this stress, a stress relieving is done. So this is all about stress relieving. See that cycle takes how much time? 3 hours plus 2 hours, 5 hours, 6 hours, 7, 8, 9, 10, or 11 hours it takes for the stress relieving to be completed. Around 10 to 11 hours, depending on thickness. This is all about stress relieving. Now, what is heat treatment? Heat treatment has got a different purpose. Heat treatment is done to refine the grain sizes and alter the mechanical properties. So this will go at a much higher temperature compared to stress relieving. Here again, 100 to 300 degrees centigrade at 100 degrees centigrade per hour. This will go up to 300 degrees centigrade. From there, you can raise 200 degrees centigrade per hour. Now, why it is done? To avoid a thermal shock. If you start heating at a very high heating rate, there will be a thermal shock. So up to 300 degrees centigrade, you raise it at 100 degrees centigrade per hour. From 300, it can go up to 200 degrees centigrade. It could be 150 as well. But more time, more slower heating rate means cycle time will increase. So you have to have economy of operation and the time. So 200 degrees centigrade per hour, and you go up to 900 almost a temperature. 900, 950, you can see here, the temperature range is much higher compared to stress relieving. Stress relieving would have been a year around 600. And for annealing, it goes up to 900, 950, 920 at that range. From there, it is cooled in a furnace. Annealing is always done in a furnace. And again, you cool it at say around 100 degree centigrade per hour. At this, you cool down, you bring it up to 300, and after that, it can be air cooled. So after 300 degrees Celsius, you can allow this to cool in the air. Now just imagine the time, 3 hours for up to 300 degree, and then 5 hours as you grow up, then 1 hour depending on thickness, 1 hour per inch of thickness if it is 1 hour, then cool down, and then it is almost 9 hours, and then from there 2 hours. So almost the cycle takes 12 hours time. The difference is it is almost 300 to 350 degree higher than the stress relieving temperature. And in this process, you are softening the material. You are not only there will be stress will be removed, there will be grain refinement. So you can create fine grain, and also the ductility will be improved. That's one of the reason of heat treatment. And one thing is it is done in a furnace. It's called annealing furnace. So preheat 100 degrees centigrade per hour, ramp up to 300 degrees, soak at 870 to 900 degree, depending on temperature based on the material grade and thickness. So from there, furnace cooling up to 300, and below which ambient. So this is how you can see annealing really works. Now, what is normalizing? How normalizing works? See, the basic difference with normalizing is actually normalizing and annealing range is almost the same. See, the range is 880 to 940. This is the range depending on thickness, depending on the material chemical compositions. This will be done at this range 880 to 940, 950, around this temperature. Here again, to avoid the thermal shock, you raise it at 150 degrees centigrade per hour up to 300 degrees centigrade, and then you gradually heat it up. Same cycle, 200 degrees centigrade per hour, you can heat it up till it reaches the highest temperature, hold at 900 degrees centigrade, 900, 850, 880, 940, 950, around this range. As I said, this will depend on the thickness of the material and the chemical compositions as well. So now from there, you hold it for 1 hour or 45 minutes, depending on the thickness. If it is 1 inch, typically keep it for 1 hour. And from there, you allow it to cool in normal air, normal ambient air. Here, only difference with annealing is this treatment it's not cooled in furnace. There is no furnace, right? So this temperature gradient is more rapid because it is happening in the air. There is no controlled cooling in normalizing process, which is done in annealing furnace. Now, it will cool down rapidly in open air. So here also, you are defining grain size, but since it is cooling more rapidly, more faster, you will have more toughness and slightly harder compared to annealing. The structure will be slightly harder and it will have more toughness. So, in other words, now if we summarize, all three, normalizing, annealing, and stress relieving, all are heating, holding, or soaking at a temperature and cooling. But for normalizing, heating, hold it, drop it rapidly in ambient air. For annealing, controlled heating up to 300, and then heating up to the peak temperature, holding it at the holding temperature, which is 1 hour per inch of thickness. From there, cool down in the furnace up to 300, and then allowed it to cool down ambient air. And stress relieving is, of course, at a much lower temperature, around 600 to 620 degrees Celsius. So these are the three differences. So in stress relieving, there is no grain refinement, only locked up stresses are released. But in normalizing and annealing process, you are refining and altering the mechanical properties of the material. Now, I would show one comparative chart which will give very interesting information. So the blue one is normalizing. You raise it to normalizing and cool it in open air. So you heat it at a controlled temperature and then raise it up, hold it, and allow it to cool in open. This is normalizing. Now, stress relieving is going up to 620 or 600 plus, and then controlled cooling in the furnace, and then allow it to cool down in open air. And in annealing, it goes up to 300 degrees Celsius. From there, it goes up to the peak temperature, what is the temperature designed for complete treatment. From there, soak it for the time, so 1 hour per inch of thickness. And from there, it is cooled down in the furnace under controlled cooling. From there, it is allowed to cool in the normal air, ambient air. So these are the three graphs. So you can see a typical normalizing process can take 8 hours, 10 to 11 hours for stress relieving, and almost 12 hours for annealing, because controlled temperature means you allow more time to cool. These are the three differences. Now, I will ask you a question. When you produce seamless pipes, so seamless pipes, do you need a stress relieving or heat treatment, normalizing, or annealing? The answer is no, most likely no. Why? Because when the pipe is formed from Madaholo, it comes to the cooling bay, the temperature remains around 800 to 900 degrees Celsius anyway. The billet is pierced, drawn, straightened, still it is red hot by the time it comes to the cooling bay, sufficiently above 850 to 900 degrees centigrade. And then it is allowed to cool. So the process itself simulates the condition of normalizing. So you don't have to separately normalize or stress relieve the seamless pipes once they're produced by hot rolling. But if they are cold drawn, expanded further, and the cold expansion is happening, in that case, you may have to do an annealing treatment to refine grain sizes. So these are basic difference and a similarity of the three processes. So in summary, I'm going to draw comparison of the three processes in a single chart for ease of your reference. Let's have a look at it. Say these are the three processes: stress relieving, normalizing, and annealing. The aspects, different aspects we're talking about. So the primary purpose of stress relieving is to reduce residual stress from welding and forming with minimal change in the properties. The temperature does not reach the transformation temperature to cause phase changes. So there is no change in the property as such other than relieving the stress. Normalizing refines grain sizes, homogenize microstructure, and improve toughness and machinability. As I mentioned, it improves toughness, ability to absorb shocks and impact. Annealing, since it is done under controlled condition and prolonged a long cooling cycle that controls the formation of mud inside. So you are going to get the softest structure. So it softens the material and you are going to get more improved ductility. Now temperature range for stress relieving is 550 to 620, 650 around this range. Whereas for normalizing, it goes up to 880 to 940, 950 around this range. Now for annealing, again, similar range, 850 to 900 degree Celsius is the temperature. It goes above the lower transformation temperature. Holding time, thumb rule, 1 hour for 25 thickness. Per inch of thickness is 1 hour. Minimum 30 minutes. That's the thumb rule. So normally 30 minutes to 60 minutes for normalizing. Again, 1 hour per inch of thickness, minimum 30 minutes is for annealing. So normally range will be 1 hour for inch of thickness, minimum 30 minutes, and normally 60 minutes, 30 to 60 minutes. Cooling method, furnace to cool up to 300 degree, down to 300 degree, and for stress relieving is also done in a furnace. So it comes down to 300 degree under controlled condition, under controlled cooling, and then allowed to cool in open air. Normalizing, it gets cooled in still air from the soaking temperature. And for annealing, again, it is cooled down at a controlled cooling rate down to 300 degrees centigrade from the temperature, soaking temperature, which is say 850 to 900. From there up to 300, it will come down at a cooling rate of a similar to heating rate, right? Now, on the microstructure, effect on microstructure, minimal effect on stress relieving because it's not going to phase a transformation range, lower transformation range, as I mentioned. But all right, in normalizing, you form austenitic structure and pearlitic, ferrite pearlite is formed. So this structure is also there in annealing. The effect on the properties, there is a very little change in the hardness is expected. Basically, distortion is reduced. But here in normalizing, improved toughness and uniformity, you will get more toughness. Charpy impact values will go up and you get maximum softness in annealing. So hardness will be considerably lower and ductility will be improved. Hardness is reduced, so which is a very good property for the material. So these are some of the application. I'm sure this comparison chart will be very handy for your quick reference. I hope the session was interesting and informative enough, and you understood the difference between stress relieving, their purpose, normalizing and annealing, and basic difference between normalizing and annealing.